Okay, so in this video we're going to take a look at a component that we can change the resistance of by changing its conditions. So the one we're going to look at today is an light dependent resistor, often known as an LDR. So this part down here, this little circle here. So the circuit we've got here, it looks like a complete mess of wires, but it's just a resistance measuring circuit. So we've got an ammeter that's in series with this LDR, and we've got a voltmeter which is in parallel. So we're just trying to measure its resistance. So if we just sketch ourselves a quick diagram of this. So we've got our power supply set at 6 volts. We've got an ammeter. We've got an LDR which has this symbol here. So it's got the symbol for resistor and then light coming in. Let's complete the circuit. And then we've got a voltmeter in parallel there. And what we're going to do is let's sketch ourselves a quick table. So what we're going to do is record what the condition is, the potential difference, the current, which will be in milliamps here because our resistance is going to be quite big, and then we'll have our resistance at the end. So the first condition I'm going to do, let's give myself a line across, we're going to do it in the dark. And we're going to achieve that simply by covering up the LDR. So I'll do that. So now no light is getting to the LDR, so we'll see our current and our potential difference change. So our potential difference, nice and easy, 5.92. So this is plugged into the 1 milliamp setting. So 10 on this top scale is 1 milliamp. So 2 on here is 0.2 milliamps there. Okay, so this will change when I take my finger off, but that's fine. So we'll do 5.92 divided by brackets 0.2 divided by 1,000. So the current is tiny here, and we can see we've got a 29,600. So I'm just going to write that as 30,000 ohms there, rounding to two significant figures there. So in the dark, we've got a massive resistance. So what we're going to do is we're going to give it some light, and I could just have it like this, but let's take it up a notch. Let's get ourselves an actual light. Here we go, we've got ourselves a light. Okay, so let's make it nice and bright. So you can see it's gone off the scale, so I'm going to quickly unplug it because I want to make the current go too high. Let's have it in there. So even on that one, the current is too big. So let's get rid of this. We'll bring ourselves in a shunt with a bigger maximum range. So again, we'll start at the top one. Okay, our current is quite small on that, so we'll change to this one. Okay, so in light conditions, we have a current. So this is a 50, so we're going to read on the bottom scale. So that is 0.7 on the scale. So that's 7 milliamps. Because 5 on the scale is 50 milliamps, so 0.7 on the scale is 7 milliamps. And our potential difference is 5.88. So let's turn off our lights before I go blind. So in the light, we had that as 5.94, and that was now 7 milliamps. We can measure to the nearest milliamp now. So normally when we're drawing a table, we would have consistent precision down here, right? But we've actually changed the settings on our ammeter, so we've actually changed its precision. So this is actually correct in this case. So let's get our resistance reading. So what was that? 5.94 divided by 7 divided by 1,000. There. So we've got that. I'm going to record that as 850 in terms of it there. So what we can see is that the lighter it gets, the smaller the resistance gets. So again, what we're seeing is, so the lighter we get, the smaller resistance gets. So it's a bit like a thermistor. So with a thermistor, the hotter it got, the lower the resistance got. And in here, the brighter it gets, the lower the resistance gets. And that's because there are similar mechanisms going on which are causing the resistance to change. We're essentially releasing more free electrons in the material, which is actually what's causing this. So that's our LDR, and this is really useful in circuits we want to measure temperature, or we want to automatically respond to changes, I said temperature, in light, the amount of light in the room. So for instance, if we want an automatic light, we can use one of these to turn on a circuit when it gets too dark, for example.